Hi guys, so for today we're going to continue our discussion of exact DE involving trigonometric functions. This is part 2. Okay? So if you haven't watched my video about part 1, you can also watch that first before proceeding with this video. Anyway, we are again to solve exact DE involving trigonometric functions. So let's get started. So we have a given of dy over dx equals to xy squared minus cosine x sine of x over y multiplied by 1 minus x squared. So what will I do first is to make this dE in this form because this is what we want, okay? In order for us to, this is dx, this is dx. So m of xy, dx plus n of xy, we have dy is equals to 0. So I have to arrange that. So we have y 1 minus x squared, we have the dy, and we have equal, or I can transpose this. So if I transpose that, let's try to do it step by step. So we have x to y squared minus cosine of x sine of x multiplied by, we have the dx here. Okay, so I'm going to transpose this on the right side. So I'll be having 0 is equals to x to y squared minus cosine of x sine of x. We have dx minus, we have a y 1 minus x squared dy is equals to 0. Okay, and that's we have an equal to 0 here. So what will happen is I would want this to become plus. So I could distribute the negative sign. So if I'm going to do that, so xy squared, if I'm going to do that, we'll be having, okay, we'll be having this, okay, plus, but this is now negative, and I can transpose the negative, okay, distribute this into this. So what will happen? I'll be having, this would be negative y plus, okay, x squared y. I've only distributed t negative y so that it would become plus. It would look like this. Okay, this would be our m in terms of xy, and this would be our n in terms of xy. And we have to perform the test for exactness. And again, the test for exactness is the partial of m with respect to y is equal to the partial of n with respect to x. So let's try first the partial of m with respect to y. So again, we have the partial of m with respect to y. We are to differentiate m in terms of y. So we considered x here as constant. So we have 2y, okay, or okay, we are actually differentiating this with respect to y. So partial differentiation. So we x is considered as constant, and we have 2x to y, okay, and minus with respect to y. So since this term does not contain any y function, again, this is considered as constant. So that would be the derivative of constant. This constant is 0. Again, this become a constant because we are in a partial derivative y. And this term does not have any y term. So that's considered as constant. Derivative of constant is 0. So the partial of n with respect to x is equal to what? So this is 0 because this term does not have any x. So with respect to x, this is plus 2xy. We consider y as a constant. We differentiate this. That is 2xy. Therefore, as you can see, it's very evident that partial of m with respect to y is equal to the partial of n with respect to x. And therefore, this is an exact DE. Okay, that is an exact DE. So what to do next? We have the formula, the partial of f with respect to x is equal to the m of x to y. Okay, that's our next step. So we have the partial of f, we have the m, which is the xy squared minus cosine of x sine of x. That's the value that we had a while ago. And then we transpose this, we have dx here. And of course, if we are to integrate this, what will happen is that we have f here and distribute integral sign in dx. So we have integral of xy squared, that's the property of integral, minus integral of cosine of x, sine of x, dx here. Okay, so we integrate. So the reason why we are integrating is to find the value of q of y and of r of x. Okay, so again, this is integrating with respect to x. So any variable aside from x is considered as constant. So we can factor out y squared, integral of x dx, okay, minus the cosine of x, sine of x dx. So as you can see, we can get the integral of this as x dx is x squared over 2. So we have x squared y squared over 2. Okay? Minus, if we integrate this is simple u substitution. We can let u as sine of x. That du is cosine of x dx. And this cosine of x dx is readily available here. So we can substitute it by u substitution. Integrate it by u substitution. So we have the u is sine of x and the du is cosine of x dx. So we have x squared y squared over 2 minus this is u squared over 2 plus q of y. Okay? Then we have x squared y squared over 2 minus, we have the u, back substitute it. So we have sine of x squared over 2 plus q of y. So that is our first value of f. Okay? So how about if we are to find again the other formula, partial of f with respect to x is equal to the n of xy. So what will happen here is that we have the partial of f that is equivalent to our n of n. Our n is negative y plus x squared y, and we distribute this. This should be partial of f with respect to y. I'm sorry, this should be y. So we have cross multiplied the dy here. Okay, so we have this, and the next step is again we need to integrate. It's very simple. Integrate it. So what will happen here is that we have f is equal to, we can distribute the integral and dy plus the integral of x squared y dy. And we are integrating with respect to y. So this would be negative y squared over 2. And we can factor out x here. So we have x squared here. We are left with the integral of y squared y dy, that is also y squared over 2 plus r of x. Okay? So I made a shortcut here in that we factor out x squared outside of the integral, get the integral of y dy, it's y squared over 2 that's multiplied by x squared. So this is our other value of f. So it's time to equate the two f. Okay, so we have x squared y squared here over 2 minus sine of x squared over 2 plus q of y here, and that's equivalent again to negative y squared over 2 plus x squared y squared over 2 plus the r of x to determine the q of y and our r of x. So as you can see, this would cancel. Okay, so our q of y therefore is a pure term in y on the other side of the equation. So this is that. So we have negative y squared over 2. For r of x is a pure term in x containing x, okay, on the other side of the equation. So we have negative sine, okay, minus sine of x squared over 2. So the DE can be found by what? By either using this or using this with the corresponding value of q of y. So let me try this. So therefore our solution, I'll get this. So we have x squared y squared over 2 minus sine of x, you have squared over 2 plus the q of y. My q of y is negative y squared over 2 is equals to, of course, c. And what will happen if I'm going to multiply it all by 2? So what will happen? Our answer would be x squared y squared minus sine of x, okay, squared minus y squared is equals to c. And we can furthermore simplify this. So if I manipulate this, this would be x squared y squared minus y squared minus, let's distribute now the squared, sine squared of x equals to z. So as you can see, y squared is common. We have y squared, x squared minus 1 minus sine squared x is equals to c. And this should be our final answer for this differential equation. Okay, let's try another example. Okay, let's try another example. Okay, so for this example, we have, for number 2, we have x minus y. Sorry, let me just rewrite. So we have x minus y cubed plus y squared sine of x. We have dx minus, we have 3x y squared plus 2y cos sine of x, and we have dy is equals to 0. So how do we do this? Okay, again, we need to make this a plus. So we have x minus y cubed plus y squared sine of x dx. If I'm going to distribute the negative sign here, this would be plus. We have negative xy squared, 3xy squared, minus 2y cos sine of x. We have dy here because that's the form for our exact d. And we can label this as our m in terms of xy, and this should be our n in terms of xy. So what will happen is, again, test for exactness, partial of m with respect to y. So we need to differentiate this with respect to y. The first term is in terms of x, so with respect to y, that would be 0. Second term is y cubed, that would be negative 3y squared. And of course, for the fourth term, we have a sine of x. Okay, that is considered as a constant. So the only thing that we are going to differentiate is the y squared. So we have 2y here. So what will happen? We have negative 3y squared plus 2y sine of x. That's the partial of m with respect to y. And how about the partial of n with respect to x? So we have an n here with respect to x. So y squared and negative 3 is considered as constant. So we have negative 3y squared here because the derivative of x is simply 1. Okay? And then we have to differentiate this with respect to x. So negative 2y is considered as constant. Okay, we differentiate cosine of x. So that is negative sine of x. So we have negative 3y squared. Negative times negative, that becomes plus 2y sine of x. And these two are equal, therefore, exact DE. Okay, and again, the next thing to do is, again, of course, partial of f with respect to, okay, partial of f with respect to x of the m xy. So we have partial of f. Our value of m is, again, x minus y cubed plus y squared sine of x. And then we have, again, a dx here, cross multiplied. So if I'm going to get the integral of both sides, so what will happen? We have f is equal to integral of x dx minus integral of y cubed dx plus the integral of y squared sine of x. We have dx here, and we are integrating with respect to x, so this would be x squared over 2, and this is, we can factor out y cubed, we have the integral of dx, we can factor out y squared, because we are integrating with respect to x, so any other variable aside from x is considered, again, as a what? That's right, that's constant. So we have y squared integral of sine of x, we have dx. So x squared over 2 minus integral of dx is x multiplied by y cubed. So plus the integral of sine is, of course, okay, negative cosine of x. So we have y squared multiplied by negative cosine of x plus q of y. So we have x squared over 2 minus xy cubed plus, or I'm sorry, minus, that should be minus y squared cosine of x plus q of y. Okay, that's our first f. Okay? So how about we find the partial of f with respect to y of the n in terms of xy. Okay? So that's how we find it. So we have partial of f is equal to the n. Our n is the distributed negative already. So we have negative 3xy squared minus 2y cosine of x. And we have a dy here. So if we integrate this, both sides, to obtain r of x, so we have f is equals to negative 3x squared y dy minus integral of 2y cosine of x, and we have dy. So we can factor out, since we are integrating with respect to y, any other variable aside from y is considered as constant. So we have negative 3x squared integral of y dy minus we have cosine of x integral 2 cosine of x. I can factor out also. So we have y dy here. So this would be what? I'm sorry, this should be a squared. Okay, I forgot. This should be squared. What will happen? Negative 3x squared. We have y cubed over 3. As you can see, this would cancel. And this is negative 2 cosine of x. This would be integral of y dy is y squared over 2. That would cancel. So we have negative x squared y cubed minus we have y squared cosine of x. Okay, plus we have the r of x. Now it's time to equate the two f. So we have this second f. So therefore we have negative x squared y cubed minus y squared cosine of x plus r of x. Okay, and that is equivalent to our value of here of f. So we have x squared. Okay, so let's go back. We have x squared over 2 minus xy cubed minus y squared cosine of x plus q of y, if I'm not mistaken. Okay, let's check. Minus y squared. Okay, we are correct. Okay, so as you can see, here, we have of course, I'm sorry, again, another problem is we don't have squared here for our x. This is simply x. I'm so sorry. I forgot that. I completely forgot that. I'm so sorry. Please forgive me. So we have 3x. So 3x, there you go. Okay? All along, that's x. Okay? So what will happen is that this would be cancelled. Okay? And what negative y squared cosine x would cancel. Okay, so what would be the value of r of x? The value of r of x is on the right side of the equation, other side, purely containing x squared over 2. And the value of q of y is the pure y containing on the right side of the equation. In that case, we have 0 because there is no term here that's purely in terms of y. So therefore, our answer, I'll be using this since the value of q of y is 0. So we have x squared over 2 minus xy cubed, okay, minus y squared cosine of x is equal to c. The value of q of y is 0, so I did not add plus 0 here. Okay, so this is the final answer for our D. Okay, I'm so sorry for some major, some minor uh, uh, terms here. So I just completely forgot. So thank you so much for listening. This is our final answer for our differential equation. Thank you so much for listening. I hope you learned something for today's video. And if you learned something for today's video, please don't forget to click subscribe and leave a comment down below and leave a thumbs up to this video. So thank you so much. Please share it with your friends, with your engineering friends. This is again Engineer Abat. Thank you so much and God bless you.